Hello, we're going to do 11.5 area of similar figures. And so let's talk about ratios to begin with. So let me get my pen ready. If you look at these triangles and label them small, medium, and large, we're going to compare the two similar triangles and find out the ratio of their sides. So if you take the two small sides, let's go with the 4 over the 6, that's 2/3. If you take the 6 over the 9, that's also 2/3. And if you take the 8 from the smaller triangle, compare it to the 12 of the other, that's also 2/3. So we can say the ratio of sides is 2 to 3. If we do the ratio of perimeters and add up the sides, we have 4 plus 6 plus 8 all over 6 plus 9 plus 12. That's going to give us 18 over 27. If we reduce that, we also get divide both by 9, 2/3. So the ratio of perimeters is also 2/3. And now let's do the ratio of the areas. If we take the area of the first triangle, it's 1/2 the base times the height. And the larger triangle is 1/2 the base times the height. So that's 1/2 of 24, which equals 12. And this is 1/2 of 27. I'm sorry, 1/2 of, I don't have it here, hold on, of 54, which is 27. And if we reduce that, we have 4/9. So that's a little bit different, right? The ratio of areas is a little different than the ratio of the sides and the ratio of the perimeter. So now that we see those similarities, let's go ahead and fill this in. The corresponding side length is 5 to 8, so will the perimeter be. And then this one, the ratio of area, we're going to square them. So that's 25 to 64, because that's what happened here. The 2/3 squared became 4/9. If the perimeters is 4/7, so is the sides. And the ratio of areas is going to be 16 to 49. This is going to be the square root of the areas is going to be 13 to 6. And it's going to be same for the sides. Now if we reduce 16 to 18, 66 to 18, divide both by 6, you'll have 11 to 3. And that'll be the same for those perimeters, and then square it for the area. So therefore, A to B is going to be the same for the perimeters, and then this will be the formula for the ratio of areas. So therefore, if a ratio of the size of two similar polygons is A to B, then the ratio of their perimeter will be the same. And if the ratio of the sides of two similar polygons is A to B, then the ratio of the areas is A squared to B squared. So now we're going to use that into some practice problems. And in this case, you can go whichever way you want. They're not asking for a certain direction. They just want to know the area of the shaded figure. So what we know is the unshaded figure. We know the area is 200. So I'm going to put that one on the bottom. I'm going to put the one we do know on the bottom. So in this case, it's going to be the unshaded for both of these. And I'm going to put the shaded on top just because that's how I'm going with it. Okay, so we already know that A squared times the B squared will give us 200. And we do see that they're giving us the side length. So let's go ahead and find out what the ratios are just using the sides. If we reduce that, that's 3 over 2. If we square both of those, we'll get 9 over 4. So we know the square of the side lengths is going to give us the area, and we know the area of the unshaded one is 200. We need the area of the shaded one. So then we can just cross multiply. 4x equals 200 times 9. X equals 450 inches squared. All right, this one is very similar. We know the side lengths. Let's go ahead and put 20 over 16. That reduces to 5 over 4. Let's see, I said I was going to do it the other way around, so I don't want to confuse you. I'm going to put 20 16. That's the same as 4/5. Square both of those. We'll get, oh, sorry, did I mean to do that? And we know that that equals the area of the unshaded one is 8050. We're trying to find the area of this one. All right, cross multiplying, we get 25x. And we get x equals feet squared. All right, this one, they're giving us the area of each. We need to find this missing side. So let's start with this one being on the bottom. 72, 50. I'm going to just put the unknown one on the top, okay? So 72 goes to the area of 50. We know that we need to square root that. So let's see if we can reduce it first by 2. And that's going to be a 36. Then we'll take the square root of each, and we'll get 5 and 6. So we know that this 5 and 6 go with the 12 and the side that we're missing. So the missing side is 10 meters. Doing the same thing over here, the one we do know is this one, so I'm going to put that on the bottom this time. That goes with this area. Let's reduce it, and we have 49 over 9. Square root both, and we're going to get 7 and a 3. That ratio is going to line up with the ratios of the sides we do have. We don't have that one. X equals 42 centimeters. All right, so that's how you can use these ratios to help you find area and perimeter. This next one has perimeter in it. So let's look at this. We have a regular octagon, 2 regular octagons. I'm just going to draw them. I always just draw whatever they tell me, even if it's not the right size, sizes. Okay, 10. And its area is 160 square meters. This one, we don't know the side length, but we do know the perimeter is 200. So if we divide that by the 8 sides, we're going to get what the side length is, and that's how we're going to have to start it. And that equals 25. So we know that this one has a side length of 25. This side has the side length of 10. And we already know the area of 1. So let's put this one on the bottom. And we're going to say 10 goes to 25 as what goes to what? So first we'll find the scale, divide both by 5, and that is 5 over 2. So the A to the B is 5 over 2. But we need the A squared to the B squared. So we're going to square them both. We'll get 25 over 4, and that's going to equal our area and our x. 4x equals 25 times 160. So x equals 1,000. What do we need? Millimeters squared. All right? Ask your teacher if you have some more questions.